Hello, students. Today's video is titled Factoring Expressions. Factoring expressions. And before we actually factor a few expressions, we need to go grab a quick definition. Here it comes. There is something in math called the greatest common factor. Greatest common factor. And sometimes you'll even abbreviate that like this, GCF. If you ever hear GCF, that stands for greatest common factor. Here's the definition. It's the largest number that can divide evenly into two other numbers. Let me read that again. It's the largest number that can divide evenly into two other numbers. For that reason, this is sometimes called the greatest common divisor because of that dividing part of it. Okay, so I'll teach you how to do this through some examples. So if we go, I'm going to go into the packet, and in the packet on our lesson here on factoring expressions, I have two bullets I'll read to start. The first bullet says, to factor means to break down. So that's super important. I'm going to circle that. Break down and factor mean the same thing. Okay, and finally, the second bullet, an algebraic expression can be factored by finding the greatest common factor, or what I just called GCF. So let's take a look at example 1. Example 1 says, factor 6x plus 9. Okay, so this is how I do it. First off, factor means to break down. So what I'm going to do is I'm going to break down 6x plus 9 by finding the greatest common factor. What I like to do is I'll put a divided by here and a divided by there. Now I'm going to ask myself this question. What is the largest number that can divide evenly into both 6 and 9? You can pause this if you need to. What is the largest number that both 6 and 9 can be evenly divided by? Well, I hope you're thinking 3, because that is the greatest common factor. It's 3. So then I do this. So now what I do is to write my answer, I take the greatest common factor, I write it down, then I open parentheses like this, and then I do the math inside. So here we go. What's 6x divided by 3? Well, 6 divided by 3 is 2, so that's going to be 2. Bring down the x, bring down the plus sign, and then 9 divided by 3 is 3. So the factors of 6x plus 9 are 3 and 2x plus 3. Very good. Let's go to example 2. Factor 4x plus 6. Okay, so I put my divided by, and then I ask myself, what is the largest number that can divide both 4 and 6 evenly? I hope you're thinking 2. So my greatest common factor is 2. So I write that out to the front. Then I open my parentheses. Now I take 4x divided by 2. Well, 4 divided by 2 is 2, so that's going to be 2x. Bring down the plus sign. And then 6 divided by 2 is 3. And that's your factored expression. It's broken down by the GCF. Let's look at the next one, example 3. Factor 12x minus 8. Okay, what are we dividing by? What's the biggest number I can put underneath these two that will divide them both and it will come out evenly with no remainder? Well, I'm thinking 4. Yeah, I think it's 4. So the 4 comes out, parentheses, then you divide. 12 divided by 4, that's 3. Bring down the x. Bring down the minus sign. 8 divided by 4, that's 2. Pretty easy. Okay, if I flip my page here, I've got 3 more examples. Here we have factor 45x minus 27. What's the biggest number I can divide both of those by? Pause me if you need to. I'm thinking it's 9. So 9 comes to the front. Open those parentheses. 45 divided by 9, that's 5x. Bring down the minus. 27 divided by 9 is 3. Example 5. What do you think? 35 and 50. 35 and 50. I'm thinking 5. So that would be 5 out front with 35 divided by 5, that's 7x minus 50 divided by 5 is 10y. And the last one, 32x plus 8y. What is the largest number I can divide them both by? Let's see. They can both be divided by 2. They can both be divided by 4. Oh, wait, I think they can both be divided by 8 because 8 divided by 8 is still 1. So the biggest would be 8. So we put the 8 in front, open parentheses, 32 divided by 8, that's 4x plus, and then 8 divided by 8 is 1, and then the y comes down. Now in math, whenever the coefficient or the number in front of a letter is 1, you don't have to write it. So this could be written like this, 8 and then 4x plus y. 1y is the same as just y. Okay, so that's how you factor. So the thing of it is, guys, is like, I know we're using letters and such here because we're doing a little bit of algebra, but I think the next lesson, let me double check this. Yeah, the next lesson, which I can allude to, is called distributing expressions. Distributing is the opposite of factoring. So kind of what I want to show you, let me go back. Let's just go back to this like first example here. Where was I? Right here. So remember we had 6x plus 9, we divided by 3, and then we got this situation. So this is how it goes. In regular arithmetic, like if I would write the number 35, right? 2 numbers that multiply to give you 35 might be 7 times 5, right? That means this is a factor of 35, and this is a factor of 35, okay? To be a factor of a number, that number, if that number can be divided by you, then you're a factor of that number. So how we check it is 2 factors when multiplied back together should give you back to your original. Okay, so if we did something like 16, some factors of 16, well, 8 times 2. So 8 is a factor of 16. 2 is a factor of 16 because when you multiply them, you get 16. If we did 21, 7 times 3. So 7 is a factor of 21 and 3 is a factor of 21 because when you multiply them, you go back to 21. So the whole thing here is once we do the math here and we find the GCF and we divide by it, and we pull it out front and then we write what's left, that means these 2 items here are factors. So 3 is a factor of this expression, 6x plus 9. And 2x plus 3 is also a factor. And when you multiply them together, you should get back to the original problem. Well, let's see if you do. And this is what the next lesson is. It's called distributing. So what you do is you take this factor 3 and you multiply to 2x. 3 times 2x is 6x. And 3 times 3 is 9. So just like 7 times 5 is 35, 3 times 2x is 6x, and 3 times 3 is 9. And so these are the factors of the algebraic expression. So I hope that makes sense. Thanks for watching, and happy trails to you.